Hi, everybody. It is week 8 in our chemistry class, and this time we're going to talk about the mole. Here's our story so far. We've been talking about the fact that atoms bond to form compounds, ionic and covalent compounds. Ionic compounds when you have a nonmetal and a metal, and covalent compounds when nonmetals react with each other. Now, these form unique, specific chemical formulas. And we've also recently been talking about how to convert units. Anything similar can be converted to each other, feet into meters, seconds into minutes, etc. One of the things that we have not talked about yet is how do chemists know exactly what a chemical formula is for a compound? How do they know that water is H2O or table salt is one sodium atom with one chlorine atom, or hydrochloric acid is one chlorine and one hydrogen? Well, it's a complicated story, and before we can really get into that, we have to know a few more pieces, and they involve things called moles, something called Avogadro's number. We have to revisit atomic mass, and then we have to discuss formula and molecular mass. So let's review something that we already know. We have talked about atomic mass on the periodic table. And if you recall, on the periodic table, every element has their atomic mass. Now, the atomic mass on the periodic table is quoted in AMUs. 1 AMU is an atomic mass unit, and that is defined as 1/12 the mass of a carbon-12 atom. So if you look at oxygen on the periodic table, its atomic mass is 15.994 AMU. Now, as I proceed forward in these talks, I am going to assume that we're going to meet at some point in time in a laboratory. And in the labs that I typically teach, we have balances and scales that give us 2 points behind the decimal. So we're going to round this off to 2 points behind the decimal. So if I round this off to 2 points behind the decimal, that's going to be 16.00 AMUs. If I look at carbon's atomic mass rounded to 2 points past the decimal is going to be 12.01 AMU. And chlorine, its atomic mass is going to be 35.45 AMU. Okay, that's the atomic mass we've talked about in the past. There is a thing called molecular mass, and molecular mass is pretty simple. If you have a molecule like water, and you want to know the mass of the entire molecule, it's easy. All you do is add up the masses of all of the atoms inside that molecule. So you sum the parts, and that is going to give you the total mass of the whole thing. So let's go through one of these. If I have a water molecule, it's going to consist of 2 hydrogens and 1 oxygen. And I have a tendency when I write these out to put oxygen in parentheses for one reason, because an O for oxygen looks a lot like a 0, so I want to differentiate those. Somehow, that's why I put the oxygen in parentheses. I can look up the masses on our periodic table. So hydrogen, and I know you can't read that, but I wanted you to know where I'm getting that number from. Hydrogen's atomic mass, rounded to 2 points past the decimal, is 1.01 AMU. And oxygen, that we just talked about in the last slide, is 16 AMU. But we have 2 hydrogens, so I'm going to multiply that by 2. So 2 times 1.01 is 2.02 plus the 16, the total molecular mass for water is going to be 18.02, and the units we're dealing with are atomic mass units. And that is going to be the molecular mass of one water molecule. Okay, if you have a calculator and a periodic table, that's not too hard. So let's do another one. We're going to find the formula mass for chalk. Now, the chemical formula for chalk is calcium carbonate. Now, why did the name change from molecular mass to formula mass? If you recall, when we were talking about ionic and covalent compounds, the smallest piece of an ionically bonded compound is called a formula unit, and the smallest piece of an covalently bonded compound is called a molecule. The process is exactly the same. It's a matter of using the correct vocabulary. So please don't let the vocabulary throw you. It's the same process. If you read formula mass versus molecular mass, I just don't want you thrown by the words. You do exactly the same thing. So let's go through this process. If I have calcium carbonate, I have 1 calcium, I have 1 carbon, and I have how many oxygens? 3 oxygens. So looking up the atomic masses on my periodic table, calcium is 40.08, carbon, 1 carbon atom is 12.01, and I have 3 oxygens, and each oxygen is 16.00. If I throw all of that in my calculator, I end up with an atomic mass of 100.09 AMUs. And units, ladies and gentlemen, are so important in science. We have to make sure we understand the units we're measuring something in. All right, if you think you kind of have this process down, grab your periodic table, grab your calculator, and try this one. This is the chemical formula for common acetylsalicylic acid, commonly known as aspirin, and find its molecular mass. And then we're going to go through this together. So hit pause, do this one, and then we're going to come back and do it together. Okay, my friends, here goes. So I have got 9 carbons plus 8 hydrogens plus 4 oxygens. And again, I'm putting these in parentheses just to keep them looking like not a 0. Now on the periodic table, carbon's atomic mass rounded to 2 digits is 12.01. Hydrogen's atomic mass 1.01. And oxygen's atomic mass is 16. When I throw those numbers in the calculator, I'm going to do the next step and write it down, because I have found Mary is not the best at having long strings of things in my calculator. If I do that, I tend to make a boo-boo, and I don't even know where that happened. Okay, so if I do the multiplication, 9 times 12, 8 times 101, 4 times 16, I get this. Then I add all those pieces together. I get 180.17 AMU is the molecular mass of an aspirin molecule. Pretty good? All right, if you want some more practice, let's do one more of these together. Please find me the formula mass of, now can you name this? Let's take 30 seconds and name this. Fe2SO4. Remember when we were naming compounds? This has got a metal in it. So is that going to be an ionic or a covalent compound? That's going to be ionic. So this is going to be iron. All right. Now, iron's one of these wacky ones that has more than one way it can bond. Is it iron 2 or iron 3? Those are the 2 different ways iron can bond. Well, that 3, when it crisscrossed, where'd the 3 come from? It came from up here. So this is going to be iron 3. And if you look on that chart of polyatomic ions, this SO4 is a sulfate. That is iron 3 sulfate. All right, hit pause, find me the formula mass of iron 3 sulfate, and then we'll do it together. Okie dokie, I've got 2 irons plus how many sulfurs? 3 applies to everything in parentheses, 3 sulfurs, plus how many oxygens? This can get tricky. 3 times 4, we're multiplying, 12 oxygens. Yeah, it's easy to miss that, 12 oxygens. So iron on the periodic table, when I look it up, is 55.50. Sulfur on the periodic table is 32.07. And oxygen, I know by heart because we use oxygen so much, 16.00. 2 times 55.0 is 11. 111, how's that? 3 times 32.07 is 96 0.21. 12 times 16 is 192. And when I add all that together, I got 399.21 atomic mass units is the formula mass of iron 3 sulfate. Why is it called formula mass instead of molecular mass? Because it is an ionically bonded compound. On our next quiz, folks, you are going to be asked to do a couple of these. If you got your periodic table, you got your calculator, it's not complicated math. You just got to add up the bits and pieces. All right, see you later. Bye-bye.